practices tomorrow. I'm gonna practice the Thursday and Friday.
We will practice tomorrow, and we have to perform the first act. All of it. A bunch of little kids are coming over.
Ooh.
No. Little children. All right, inverse function.
Inverse.
Inverse function. All right, you know what inverse means?
I forgot, but I think you know what it means.
What do you think it is?
It's split.
Yeah, I guess you could say that. Like, what's an inverse of multiplication?
Division.
Division.
It's the opposite.
Okay, yeah, so it's like one undoes the other. They're sort of like opposites, but not really opposites. Opposite has to be signed.
Now, where's the word function?
Has everyone in this room taken a test at this point?
Yeah.
You have not. Okay, then I'm not going to give my little speech yet. All right.
Dang.
Okay, inverse functions, they are flip, they are opposite, they're reverse, whatever. Basically, inverse functions, if two functions are inverses, then one's domain is the other one's range, and one's range is the other one's domain. Okay? So you could say they switch domain and range. Domain of one is the range of the other. Which one's domain?
Domain's the bottom. No, the
Okay.
X. Yeah, my bad.
But we do have to restrict the domain to the bottom, right? And the range is the y. So
So we just flipped it like
like
3-2.
yes. 3, 2. That's 9. 68. That would be these two relations right here would be inverses. Okay? Because this one's range is that one's domain, and that one's domain is that one's range, and vice versa, and all that. Okay? Now that brings us to a question. Do all functions have an inverse? And they're not going to. If you think about it, 2, 1, 3, 8, 4, 1. Alright, think about those points. Those points could qualify as a function because x does not repeat, right?
Switch them, X will repeat.
Switch them, x will repeat, exactly. So while this may be a function, its inverse is not a function. Okay? In order for a function to have an inverse, it must be what we call 1-to-1. Okay, 1-to-1. And 1-to-1 means that the x's don't repeat and the y's don't repeat. Okay. Now how we test for a function with the vertical line test? We can test for 1-to-1 with a horizontal line test. Alright, so I'm going to ask you to use your brains for a minute.
I'm out.
I know. Hold up. Gotta use our brains. Alright, if they have to pass a horizontal line test, let me show you. That way. That's a horizontal line.
Right.
What kind of functions are automatically out for having an inverse?
Parabolas.
Parabolas are out. What else? Is parabola a hypotenuse? What? Circles, they don't even function. Yeah, they fail the vertical line test. Yeah, basically any even function. Because what happens with even functions? functions have matching in behavior. They're going to end up or they're going to end down. So anything that has matching in behavior, an even function, is going to fail the horizontal line test. Some odd functions fail. The only way to pass is to be constantly increasing or constantly decreasing. Which means functions like you can have a cubic, but it has to always be increasing, or it has to always be decreasing. You know the ones that we have that are lumpy? That's not, yeah, that's not going to have an inverse. Katie Beck has gotten to the point where she'll ask you a question that you have no idea what the answer is. Like, this is what we have for snack today. I don't know. What? No, you have to guess. Cheese puffs. Wah, wah, wah. You're like, okay. I got it.
I guess I got that.
I guess, yeah, I guess I'm wrong. Okay. But yeah, it's really pleasant. Wah, wah, wah. Oh my gosh, where did you even learn that? What? Well, she would be here anyway. She's so yeah. Inverse functions. Write an inverse. This is this is a function. We write an inverse like this. The inverse of f of x. And it looks like that. Okay. That's not to the -1 power. That's not what that is. Looks like it, but it's the inverse of f of x. We can test if functions are inverses by composing them. That's how we did composition of functions. So we will be graphing. Yeah. So right here, I want to know if these are inverse functions. So I'm going to do a composition of functions. I'm going to do f of what I believe to be the inverse of f of x. So 2 times 1/2 x is x. The inverse of f of x. So 1/2 times 2x, x. If you compose what you believe to be inverses, and the answer is just x, then they are in fact inverses. Okay? That's why we had to do composition of functions yesterday, because we're doing inverses today. Every time I teach you something in math, it's because we need it later. Alright? So to test if functions are indeed inverse functions, you do composition of functions. You knew you want to try. How about this? How about
That's my
alright, here we go. I'm gonna give you a second. I want to. Alright, so let's
Oh my
do
god, I'm not.
Sorry.
Oh.
1/3 3x minus 6 plus 2. 1/3 times 3 is 1. 1/3 times 6 is -2. -2 plus 2 is x. Then over here I'm going to go the other way with it. 3 times 1/3 x plus 2 minus 6. X plus 6 minus 6 is x. Let's talk about one more thing. Finding an inverse. Finding an inverse is really, it's easy. There's some steps to follow. It's kind of time consuming, but it's easy. The first step is, well, I don't even know when you write it down. The they give it to you in f of x, and you need to change f of x to y. Okay? I'll write it down. Change f of x equals to y. Because the second step is to switch x and y. So everywhere you see an x, you write a y, and everywhere you see y, you write an x. And then solve for y. Yeah, how about I actually like over y. And then the last one, you're going to rewrite, instead of y, rewrite it as the inverse of x. So I'll let you write those down real quick, and then we'll actually do one together on the screen. So everyone who's skipping today to go to Story Minute is doing. Alright, you have them? Alright, we're going to find the inverse of f of x equals 2x plus 1 over x. Alright, rewrite it. Y equals 2x plus 1 over x. That was the first step. Or a fourth of the way down. Alright, what's the second step?
Oh, wait.
No.
You switched the one.
Switch, so x equals 2y plus 1 over y. Alright, we're halfway there.
So,
Solve for y. That's going to be xy equals 2y plus 1. I'm trying to solve for the y. Move the y over so all the y's are together. Y minus 2y equals 1. Remember, all that factoring I told you you're never allowed to forget, ever, your whole entire life. You factor out a y. That's going to leave you with x minus 2 plus 1. And then what do I have to do to get y by itself? Oh, let's see. Good. You're a genius.
I don't know about that.
So the inverse of f of x is 1 over x minus 2. So